Hi all. In this video, we will discuss about our second sorting technique, which is selection search. In our first sorting technique, bubble sorting, in step, we are performing so many swapping of numbers. In the case of selection sort, instead of performing multiple swappings, only one time swapping per step. So that is the main difference between our first sorting technique and this particular second one, selection sort. So now we'll continue our discussion on selection sort. So by taking array of size 5. So array elements is 9, 3, 5, 2, 7, we consider as our array elements. So here, how to perform this particular selection sort is step 1. In this case, first we have to start from 0th position. So assume I is equal to 0. Next one, we have to assume our minimum element is present at ith position. So minimum position equal to I. So where I value is 0. Now our minimum position is 0. That is, we are assuming at that particular position, we have the minimum value. After that, we have to start our comparison with its next elements up to last position. So that is what we have to compare A of minimum position value with its next position. So that is what is the next one? A of 1. So A of minimum position, what is the value we have? So that is A of minimum position, A of 0. The value present at 0th position is 9. So 9 we are comparing with its next position element is 3. 9 is greater than 3. So what is the meaning of that one? What is the meaning of that one? Here our assumption is wrong. Minimum position is not present at 0th position. Minimum value is not present at 0th position. Minimum value is by seeing only this comparison, we have to change our minimum position to, okay, so to 1. Why you are changing to 1? 3 is present at first position. Okay, so the array index starts from 0. So at 0th position we have 9. At first position we have 3. At second position we have 5. At third position we have 2. At fourth position we have 7. Array index. So now minimum position is changed to 1. So again we have to compare A of minimum position. So what is our current minimum position is 1. So A of 1, what is the value of that one? 3. So we have to compare this one with its next element. 3 is greater than 5, which is wrong. So our minimum element is our up to this point, minimum position is 1 only. There is no need to change its minimum position. So 3 with 5 comparison failed. Now we have to compare with this next element 3 with 2. So 3 is greater than 2. Condition is satisfied. That means we have to change our minimum element position. So MP equal to which point we have to change? Where 2 is present. Where 2 is present in the array? 2 is present in the third position. So our minimum position is a 3 now. Change it to 3. So now A of minimum position, we have to compare with this next element. Up to this point we completed. What is next element is a 7. So A of 3 equal to 2. So we have to compare that one with the 7. 2 is greater than 7. So there is no need to change because this condition is a fails. So what is the minimum position we got finally? 3, because up to 7 is the last element. No more elements are there to compare. So final minimum position what we got? Minimum element position what we got? 3. So uh, after once all the elements are completed, we have to perform swapping of A of I with A of minimum position. So what is I value? What is I value we have started? I is equal to 0. So A of 0 we have to swap with the A of 3, where minimum position is a 3. So what is the value of A of 0? A of 0 is 9. A of 3 value is 2. We have to swap those two. So what is the result of step 1 is only those two values we are swapping. Those two position values we are swapping like this. So this is the output. This is the output of step 1. So after completion of step 1, we got the required elements to the minimum level. That is a starting position. That is the least element comes to the starting position. Next, step 2. In the case of step 1, we assumed minimum element position is 0 and I because that is the starting one. Here already we got least element to the particular position. So we have to start from this position. That is I is equal to 1. That is what we have to assume here. We have to assume minimum position equal to I, which is nothing but 1. So that is minimum element position is a 1 we are assuming. So what we have to do? We have to compare A of minimum position with its next elements. So that is A of 1, which is nothing but 3. So 3 we have to compare with its next element. 3 is greater than 5. This is not true. So there is no need to change minimum position. So what is next element? 9. So 3 is greater than 9. So 3 is greater than 9. That is also wrong. So there is no need to change minimum position. Next, what is the next element? 3 is greater than 7. That is also wrong. So there is no need to change minimum position. So our minimum position is as it is, no change in that one. 1. So finally, at the end of the thing, what we have to do? So A of I and A of minimum position we have to swap because both are same. I value and minimum position value are same. So there is no need to do anything here. So what is the output of second step is 2, 3, 5, 9, 7. So that is end of step 2. Now we will take our step 3. So in step 1 and step 2, in step 1 we started from 0. In step 2 we started from 1. Here we have to start from 2 because our minimum position we have to assume our minimum value present at the second position. Okay, already 0th position and first position is over. Okay, now we are starting our process from second position. So what is the output of step 2? 2, 3, 5, 9, 7. So here we'll take that output 2, 3, 5, 9, 7. So what is the minimum position we considered? 2 here. So that is the 2 position. What is the value as 5. So A of minimum position So that is A of 2. What is the value is 5. So that position element we have to compare with its next element. 5 is greater than 9. Condition fails. There is no need to change minimum position. 5 is greater than 7. Condition fails again. There is no need to change minimum position. So all the elements are completed. So we have to swap A of I with A of minimum position. Both are same. I and minimum position value are same. There is no need to perform any swap there. Okay, already 2, 3, 5, 9, 7. So this is the thing. So up to this point, up to second position, we got the sorted array. Next one, step 4. So already we have started from 2. Now we have to start from the 3. So that is I is equal to 3. So what we have to consider? We have to assume minimum position as a minimum element position as 3. So here, what is our array? That is output of step 3, this one. So at A of minimum position. So what is the minimum position value? 3. At A of 3, what is the value is there? 9. So we have to compare that one with its next element. 9 is greater than 7. So that means we have to change our minimum element position. Minimum element position. So what we have to take? 4. Why you are taking 4 there? That is the position of element 7. So elements are completed. What we have to do? We have to swap A of I with A of minimum position. So I is A of I is value is 9. A of minimum position value is 7. We have to swap these two. Okay, after swapping these two, what you will get? Output 2, 3, 5, 9, 7. So now what we have taken? We have taken an array A whose size is 5. Some 5 elements we have taken. We arranged, we sorted that particular array by using selection sort. Okay, so here, what is the size of the array we considered? We considered size of the array is size of array is 5. Assume size of array is n. So how many steps? Number of steps. Number of steps is n minus 1. In our example, 5 elements, 4 are the number of steps we performed. So here also, if first this is a first element is greater than, that is minimum position element is greater than our next position element, where what we are taking, we are changing the minimum position. So by performing this, you will get the ascending order. So if you take otherwise less than, if you take, you will get the descending order. So that is about selection sort. So now we will take a program for this particular selection sort. So by taking online compiler, we will take the selection sort program. Here, selection sort declaration, function declaration, and up to this point, we have taken the size of the array and number of that is size of the array is nothing but number of elements in the array. Next one is all the elements we have read, and the function calling. So function call. Okay. Now we'll define that particular selection sort function. Selection sort. So int a, array and n. So here we require to use nested loops and minimum element position. To perform swapping, we have to use this particular temp location. That is by using third variable, we are performing our thing. So here, this is outer loop, mainly refers to number of steps we are performing and -1. Okay, because we are starting from 0. So n-1 positions we are going. Next one. So in every step, what we are taking one assumption. That is, what is that assumption? Our minimum value is present at ith position. So minimum value position is I. So inner loop. So observe, at every step we are starting from next position. Our comparisons, how we are starting from its next position. That is I plus 1. So I is 0, we are starting our comparisons from first position. I is 1, we are starting our comparisons from second position, like that. So we are doing up to, we are continuing our comparisons up to last position. That's why we are taking j is less than n. So when we are changing minimum position, so when you are changing minimum position, if minimum position is greater than a of j, then what we are doing? We are changing the minimum position to particular j. So this one, we are continuing up to end of this particular particular array. After that, we are swapping the elements which are present at the ith position with element which is present at minimum position. By performing that, you will get the minimum element to ith position. Okay. So at every step, after completion of first step, you will get the required element to 0th position. After completion of second step, you will get the required element to first position. So like that, all the elements reach to their required position. Now we will execute our program. So size of the array is 5 elements. 5 elements we are taking 3, 2. So we'll get the result is 2, 3, 5, 7. So like that, we can perform our selection sort. In the case of selection sort, we are performing swapping only one time per step. So that is the thing we have to consider. Next one is complexity for the selection sort is big O of n square, because nested loop we are using one loop present in another loop. Thank you.